Okay, picture this. You're standing there right at the start of your shift. You've got your full PPE on, hard hat is secure, safety glasses are on, gloves are ready to go. You're staring down a close-up of lockout-tagout locks on a breaker panel. Now, this right here, this is where safety actually begins. Welcome to this explainer. I'm absolutely thrilled to have you with us today because we're going to walk through the critical step-by-step process of a safe jacking system repair job. And look, this isn't just about ticking boxes on a form. It's about mastering the standard operating procedures that literally keep you and your crew alive when you're dealing with massive mechanical forces and high voltage. So let's jump right in. All right, here's our roadmap for today. First up, the job safety analysis. Then we'll cover the alternate power trap, move on to the 2-brake limit, and finally, the 2-person rule. And hey, keep an ear out for a little cognitive anchor as we go through this. I call it the rule of 2. Section 1. The first step, JSA. This is everything that happens before repairs even begin. So I've got a question for you. What absolutely must happen before you touch a dust cap or a torque wrench? Honestly, before you even connect a single plug. The stakes here are just incredibly high. A jacking system is loaded with stored energy and massive weight. You really can't afford to just figure things out on the fly. You need an absolute first priority established before your hands even get near the machinery. Well, here's the answer. You complete a job safety analysis, or JSA, period. This is a stark, totally non-negotiable rule. And remember, the JSA isn't just some piece of paper to sign. It's a mental and physical roadblock. It forces you to think through every single hazard before it has a chance to hurt you. According to Standard Operating Procedure 307, this is an absolute 100% requirement for both popping and torquing operations.
So what's actually on it? Well, your JSA has to map out some very specific hazards. You've got to account for the stored spring energy that's coiled up right inside the brake. I mean, that is a massive physical force just waiting to be unleashed. Then you have to evaluate the potential for uncontrolled rig movement. You need your electrical isolation requirements firmly established. Are you working at height? Well, that goes on the JSA too. And finally, you identify the 2-person minimum for specified tasks. You've got to plan for all these hazards before stepping foot anywhere near the equipment. Now, before releasing any brake for an inspection, you have to execute a pre-check for torque equalization. First, you confirm the torque has been recently equalized for that specific leg. Why? Because an equalized leg distributes the load evenly across all the brakes. The payoff here is huge. If one high-torque brake is released safely, the remaining brakes are going to share that load equitably. The absolutely crucial takeaway here is that if you skip this check, you're risking a catastrophic overload on the adjacent brakes the very second you remove one. You've just got to respect the physics of the platform.
Moving on to Section 2, the alternate power trap, focusing on our LOTO procedures. All right, you really need to separate the electrical sources in your mind here. On one side, you have the jacking motor circuit. That's your main power. On the other side, you have the rig lighting panels, which actually power the space heaters. Now, it's incredibly easy to just throw the main jacking motor breaker and assume the whole system is completely dead. But as SOP 3.111.2 explicitly warns us, the motor and the brake space heater power come from entirely alternate sources. Isolating the main motor breaker does absolutely nothing to de-energize the space heater. If you open that assembly assuming it's dead, you're stepping right into a trap. And that brings us to the first application of our rule of 2. Since we're dealing with 2 entirely separate circuits, the main motor and the space heaters, you have to identify and isolate the space heater supply circuit separately. What does that mean? It means 2 separate lockout-tagout applications. 2 locks, 2 tags. You always want to verify with your supervisor exactly which lighting panel feeds the space heater for the brake you're servicing. Only when both are completely isolated is the assembly actually safe to open. Of course, once the repair is all done, you have to bring the system back online safely, and this requires a strict reverse order process. Step 1. You restore the space heater power from the lighting panel first. Only after that's done do you move to Step 2, which is restoring the main motor breaker in the jacking control panel. Doing it in this exact sequence ensures the system re-energizes in a stable, completely predictable way. All right, Section 3, the 2-brake limit, which covers our physical operational limitations. Here, we see the rule of 2 popping up again, and it's not just for locks and tags. This number is actually the absolute maximum number of brakes per leg that can be out of service for inspection or damage at any one time. Not 3, not 4, just 2. And that limit exists for a very critical reason. Releasing more than 2 brakes per leg puts undue, frankly dangerous stress on the remaining brakes, especially if you're operating in drilling mode. SOP 3.10 makes it crystal clear. You're compromising the physical integrity of the entire platform if you ask the remaining brakes to hold a load they just weren't designed to support on their own. You absolutely must not put the platform back into service until the required repairs have been fully implemented. I really want you to listen to this stark warning. You do not jack, you do not drill, you fix brakes first. Let that sink in. If a brake is out for inspection and another one happens to fail on that exact same leg, your rig immediately goes into protected status. The mission stops, production stops, the one and only priority becomes restoring the mechanical integrity of that leg. Building on that, there's an absolute mandate when it comes to emergency repairs. If you find yourself conducting emergency repairs during active jacking operations, the entire jacking system must not be operated while those repairs are underway. No exceptions whatsoever. You can't just inch the rig. You can't make a minor adjustment. Literally, all system movement halts entirely to protect the personnel who are working on those massive, vulnerable components. Moving into our final section, Section 4, the two-person rule for hazardous tasks. Once again, our rule of two makes an appearance, and this definition is vital. The two-person rule is a strict mandate that requires two fully focused people for hazardous tasks. It is never one person trying to juggle two jobs simultaneously. Look, this isn't just a friendly suggestion for when you happen to have extra crew lying around. It is a structural requirement of the SOP. Why? Because you're handling high-energy components that demand complete, undivided attention. This basically translates into a really clear buddy system for major operations. For brake disassembly and inspection, you need Workman 1 and Workman 2. For an LT after rig move torque, Person 1 is dedicated entirely to the popper, while Person 2 is solely on the torque wrench. For a national after rig move torque, you've got one person on the release bar and the other on the torque wrench. And for stored energy release, say if a shaft gets stuck, one person manages the wrench while the second person strictly controls the release knob. You're dividing these distinct responsibilities so no single person ever gets overwhelmed. So, the golden rule, never ever attempt these tasks solo. The harsh reality of this job is that your partner is your physical safeguard against sudden, uncontrolled component movement. When you're dealing with this kind of massive stored energy, things can shift or release violently in a fraction of a second. Your partner is literally keeping you alive. They're watching the angles you can't see and controlling the release points that you just can't reach. We've covered a lot of really critical ground today. We started with a mandatory JSA and the torque equalization checks. We navigated that dangerous alternate power trap by using 2 locks and 2 tacks. We respected the physical limit of the 2 brakes per leg rule, and we established that life-saving 2-person buddy system for physical execution. So as we wrap up this explainer, I want to leave you with one final provocative thought to take into your next shift. Are you and your partner truly ready to work safely? Keep that rule of 2 in mind, respect the procedures, and please stay sharp out there.